I just wanted to make a quick tutorial video using the technique of dimensional analysis to do problem solving. Here in Chapter 1 this is important, but more so it becomes a very important technique as we do more chemistry problem solving later in the semester. So I'm going to set up all of our problems this way. First thing we need to look for is what is it that we're trying to find and what is the given piece of information that we should use to get there. So that's the first thing that I'm going to look for. The next thing that we're going to look for are equalities that may be in the problem, they may be given, or we may have to look for them elsewhere. The inside back cover of your textbook lists several, and then we need to develop a plan to get to the desired unit from the given unit. It may require more than one step. So a sample homework problem that someone emailed me is that you're driving 123 kilometers per day, so how much money would you spend on gas in 1 week? And then you're given some various information about the car that you're traveling and how much gas costs and things like that. So immediately I would just go ahead and multiply 123 kilometers by 7 so that we can figure out how much we're going to be traveling in 1 week. So on average 861 kilometers. So this is what I'm trying to find. I'm going to travel this distance, 861 kilometers, and what I'm trying to find is how much that's going to cost me. The rest of this information given in the problem, this piece of information, this piece of information, this piece of information, these are all equalities that the problem is giving me. Relationships that I'm going to use as conversion factors. So one of them is a liter of gas costs 1.10 euro. 1 gallon of gas is what you would use up in traveling 35 miles. So notice how the problem gave it to me as, you know, a gas mileage, but I'm going to write it down as an equality. I will travel 35 miles and use up a gallon of gas, or for every gallon of gas I use, I can travel 35 miles. Each of these equalities can then be written in the form of a fraction, either like this, or we can flip it and use the reciprocal in our conversion factors when we do the problem solving. So you'll see that in just a minute. Another equality given in the problem, 1 euro is $1.26. And then finally, I'm going to also need to know a relationship between kilometers, which is the distance I'm traveling, and miles, which I know my gas mileage in miles. So another equality, and this is actually given earlier in the problem, is a relationship between miles and kilometers. So each of these pieces of information will be used in my problem solving. So I can't convert kilometers directly to dollars, because if you look in all of these relationships, none of them relate kilometers to dollars. Instead, I have a relationship, and here's where we develop our plan. I have a relationship between kilometers and miles, and then I have a relationship miles to gallons. Gallons, I really need to know how those are related to liters. And then I can convert liters to euros and euros to dollars. Okay, so I'm actually needing one more equality that I'm going to have to find. Probably in the inside cover of the textbook you'll find this one, and that is that 1 gallon is equivalent to 3.78512 liters. So this is going to require quite a few conversion factors linked together. So I would show it set up like this, 861 kilometers. Then convert kilometers to miles because I know my gas mileage in miles. So I get the relationship right here from the equality. 1 kilometer is 0.6214 miles. Once I have miles, I convert to gallons. I know that this car gets 35 miles per gallon of gas. That was also given in the problem. Gallons must then be converted to liters. The metric volume unit, 1 gallon is 3.785412 liters. Okay, that one we had to look up. And in this problem, we're told that a liter of gasoline has a cost of 1.10 euro. So when you buy gas in Europe, it's by the liter, not by the gallon. And then I can convert euros to American dollars. 1 euro is $1.26. Now, this makes a pretty complicated problem fairly simple if you just link together all the necessary conversion factors. To find the final answer, we simply need to multiply 861 by 0.6214 times 3.785412 times 1.1 times 1.26 and divide by 35. Alright, so hopefully if I haven't made any errors in here, that's set up correctly, and we should be able to solve any dimensional analysis problem if you know where you're going and you have the required equalities to get you there.